Good morning, students. We already studied the equation of motion, that is v is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2as. We have seen its proof by calculus method. Today we are going to study the equation of motion of freely falling body. First, try to understand about the free fall. The free fall is defined as a situation when a body is moving only under the influence of Earth's gravity. It is called free fall. Simple example for it: when we drop a ball, let's say from top floor of the building, then till it reaches the ground, the ball is said to be in free fall motion. Here we have to see the equation of motion of freely falling body. See, in this case we are just taking A is equals to G and S is equals to H. We are putting this in our equation of motion. Our first equation of motion is V is equals to U plus AT. Instead of A, we are putting G. So what this equation will become? V is equals to U plus GT. Okay. Second equation of motion, in that just we are putting S is equals to H and A is equals to G. So what this equation will become? H is equals to ut plus half gt square. Third equation of motion, v square is equals to u square plus 2as. Instead of a, we are putting g, and instead of s, we are putting h. So what this equation will become? V square is equals to u square plus 2gh. So these are the three equations of motion of freely falling body. V is equals to u plus gt, h is equals to ut plus half gt square, and v square is equals to u square plus 2gh. Now let us try to understand about the relative velocity. What is a relative velocity? Relative velocity of object A with respect to object B is the rate at which object A changes its position with respect to object B. See, for that VAB is equals to VA minus VB. Here VA and VB be the velocities of object A and B respectively. Then we can write its relative velocity of object A with respect to object B is VAB is equals to VA minus VB. Similar to that, the relative velocity of B with respect to A is just change, that is VBA is equals to VB minus VA. So these are the two formulas for the relative velocity. VAB is equals to VA minus VB, that is the relative velocity of A with respect to B, and VBA, that is the relative velocity of B with respect to A, and VBA is equals to VB minus VA, and is the rate at which the object A changes its position with respect to object B. Okay, so let us try to understand a small derivation related to it. Here we have to consider the two objects A and B. They are moving uniformly with velocities VA and VB respectively. VA is the velocity of object A and VB is the velocity of object B. Let XA0 and XB0 be the positions of object at a t is equals to 0 from the origin. The time is what here? 0. And xa0 and xb0, these are the positions of object A and B respectively. Therefore, the position of two objects after time t is given by, okay, we have to take here two equation, that is xat is equals to xa0 plus vat. This is the first equation, and second equation is xbt is equals to xb0 plus vbt. Just we have to subtract equation 2 minus equation 1. So what it will be? Xbt minus xat is equals to xb0 minus xa0 plus vb minus vb minus va into t. Okay, so what is this? Xbt minus xat is the relative displacement at a time t, and xb0 minus xa0 is a relative displacement at a time t0. T0 means what here? Initial time, and that is a 0. So that's why xb0 minus xa0. Here we have got vb minus va. What is this? It is a relative velocity of b with respect to a, and you already know the formula of relative velocity for vab, that is va minus vb, and vba, that is vb minus va. So this is about the relative velocity. It is a short derivation for relative velocity. Let us try to understand the graphs of it. See the special cases here. The first, when two objects move with equal velocity. We already studied the equation for it, that is VAB is equals to VA minus VB. Here the two velocities are equal. So VA is equals to VB. It means that the two objects stay at a constant distance apart during the whole journey, and in this case the position time graph of two objects are parallel straight lines as shown in figure. You can observe the figure carefully. The two lines, straight lines, are parallel here. So it means that the two objects stay at a constant distance apart during the whole journey. Next here, when the two objects move with unequal velocity, VA is the velocity of A object and VB is the velocity of B object. Here there are two cases when VA is greater than VB. When two objects move with unequal velocity. Here the first case we have taken, VA is greater than VB. At that time VB minus VA is negative, because VA is greater than VB. This shows that the separation between two moving objects will go on decreasing. Okay, will go on decreasing with time. After some time, the two moving objects meet. Here you can see the meeting position. After some time, the two moving objects meet, and relative distance between the object will increase with time. Here the relative distance between the object, it is increasing with the time. You can see in the figure. Same like that for a second case. Here in second case, VA is less than VB, or you can say the VB is greater than VA. So here if you will see the equation for it, you already know. We have seen VAB is equals to VA minus VB. See here, when VB is greater than VA, then VB minus VA is positive, exactly opposite of previous. This shows that the separation between two moving objects will go on increasing. And here the two moving objects will go on increasing with time. You can see in figure. So these are the special cases of relative velocity. In first case we have seen the two objects moving with equal velocity. They are showing parallel straight line. But in second case, here are two cases. VA is greater than VB and VA is less than VB. So try to understand these two graphs when the two objects move with unequal velocity. So we have seen about the equation of freely falling body and relative velocity. Thank you.